Okay, so in this video we're going to talk about these asymptotes we've been drawing and we want to discuss how we can actually find these. So I've got our horizontal and vertical equations for our ellipses. We're going to talk about the equation of these asymptotes. And so we're always going to pretty much do these when the center is at the origin. We don't do too much with the asymptotes other than the fact that we need to come up with the equation. And here's the easiest way to do it. Because of the origin, we know that slope is equal to the change in y over the change in x. So we look at our y value and we look at our x value, and we always put the number underneath y. Now it's not going to be b squared, it's going to be b over a. Or if it's vertical, notice that we got an a down here and a b right here, so it would be a over b. So the quickest way to do this is if I had an equation where I wanted to find or if I had a hyperbola and I wanted to find the equation of the asymptote, and I'm just going to give you an example here. Let's say I had y squared over 16 minus x squared over 9 is equal to 1. Well, I know it's change in y over change in x, so real quick I just look what's the square root of 16, what's the square root of 9, it's 3. Y is equal to plus or minus the square root of 4/3. And then that would give us our crisscross for our our asymptotes. And so by that same rationale, if I had x squared over 25 minus y squared over 64, I know slope is change in y over change in x. So I just isolate that y value and think about that first, find it first. I know I'm going to have a y equal a plus or minus, and then it's 8 over 5x. So I just look for change in y over change in x, find the y first, that goes on the top.